In this video, we're going to do the Unit 1 test review on absolute values. First, we're going to start by solving absolute value equations. Example number 1 states that we have 3 multiplied to the absolute value of 4 minus 5x, then added by 7 to equal 25. We have to get the absolute value all by itself in this equation before we're able to solve. So I first start by subtracting 7 on each side, cancels out on the left, and 25 minus 7 is 18 on the right. And then I have to divide away that 3 to cancel it out on the left. 18 divided by 3 is 6 on the right. Now that my absolute value is all alone, I can split these equations, or this equation specifically, into two possible solutions. The first possible solution is that what's inside my absolute value, 4 minus 5x, will equal a positive 6. My second possible equation, we'll go ahead and do it up here, is going to be 4 minus 5x, still keeping what's inside the absolute value, but now equaling it to a negative 6. See that I changed the sign on the right side of my equation, not changing what's in the absolute value. Solving my first equation, I go ahead and subtract 4. Cancels out on the left side, and 6 minus 4 is 2 on the right side. And I go ahead and divide by a negative 5 on each side. Cancels out on the left, and I'm left with negative 2/5 on the right side. Second equation, same thing. I'm going to subtract 4, but now it does still cancel out on the left side, but becomes a negative 10 on the right side. And then I still divide by negative 5. Still cancels out on the left, but now this results in a positive 2 when I divide negative 10 by negative 5. Now we have to do our checks. So I'm going to go ahead and check my first one, which is a fraction. Well, we still do that back in the original given equation. 3 times that absolute value of 4 minus 5. In place of x, I'm going to put a negative 2/5 plus 7 equaling 25. Checking that out, we go ahead and do our order of operations, telling me to do the inside multiplication first. Now careful here because I can put 5 over 1 and cancel out on the diagonal anything that is a common factor. So I see on this diagonal here, 5 can be divided by 5, and so can this 5. And when I do 5 divided by 5, it's 1 each time. Then I also see I can cancel out the two negatives to make it a positive, and I'm left with just 1 times 2 up top, which is 2, 1 times 1 on the bottom, which is 1. 2 divided by 1 is 2 there. Keep going with the order for operations, tells me to do 3, keep the 3, but inside the absolute value, I do 4 plus 2, which is 6. From here, I take the absolute value of 6, which is still just 6. Then PEMDAS and GEMDAS tells me to do the multiplication first, and then add 7 to get 25. And that checks out. So that negative 2/5 is indeed a solution. Over here, I'm going to check my possible x being 2 into the original problem. Again, 3 times that absolute value of 4 minus 5. Instead of x, I'll replace it with 2 plus 7 equaling that 25. Order of operations again tells me to do the multiplication on the inside of my absolute value first. Then I'm still going to work on that absolute value because of grouping and PEMDAS here. Well, GEMDAS and PEMDAS tells me to do the grouping first. Once I get that grouping down to one number, 4 minus 10 is a negative 6. I can then take that absolute value. Absolute value of negative 6 is 6. Then it's the multiplication of 3 times 6 that happens first, which is 18. Added by 7 gets me a 25. That also checks out, so that is a valid solution. Number 2 needs to again be started by getting the absolute value by itself. We go ahead and break this down to subtract 5 on each side. Since you always want to move what is not directly attached to your absolute value, like that -8 is with the multiplication. Subtracting 5 cancels out on the left, and -75 minus 5 gets me a -80 on the right. I then divide each side by -8 to get the absolute value all alone. Cancels out on the left, leaving me with just the absolute value, equaling the right side. -80 divided by -8 is 10. Now, and only now, when the absolute value is by itself, do I go ahead and break it into two possible solutions. Keep the inside, the 2x equaling a positive 10, and then keep the inside of the absolute value again, but it now equals a -10. That's my two possible answers. We solve those equations down by dividing both by 2. First possible solution is x equals a positive 5, and second possible solution is x equals a -5. We go ahead and do those checks accordingly here. You plug it back into the original problem, checking out the positive 5 first by saying that 5 minus 8, absolute value of 2 times 5, equals -75. We go ahead and solve the absolute value first. 2 times 5 is 10. Absolute value of 10 is 10 indeed. Then we do the multiplication as part of our PEMDAS GEMDAS first. -8 times 10 is -80. 5 minus 80 is indeed a -75. So that x equals 5 is a solution. We're going to go ahead and check -5 now. So I can kind of use that same check just to save some space here. But I'll erase and replace what's inside my parentheses with a -5. So now I go ahead and solve this one down. 5 minus 8 times the absolute value of 2 times -5 would make it a -10 inside. But I know that a -10 in the absolute value is actually going to come out to be a positive 10. We just did all this math. -8 times 10 gave me -80. And 5 minus 80 is indeed a -75. So that checks out. X -5 is a solution. Next example number 3, we again start by getting the absolute value all by itself. It is multiplied by this -5. Remember, there's like a multiplication between the two, -5 and absolute value there. So opposite of multiplication is division. Dividing each side by -5 cancels it out on the left, leaving me with the absolute value of 3 minus 2x, equaling 20 divided by -5, a -4. We stop right there because this is our no solution case. No need to go further because an absolute value can never be equal to a negative. So we got the absolute value by itself, and now it's equal to a negative number, which is not possible, no solution. Solving the next equation, we see that we have the absolute value all by itself because it's the absolute value of 3x plus 18 equaling 6x. So I should go right away to splitting my equation into the two possible solutions. Keep the inside of the absolute value as 3x plus 18 equaling 6x. And I still keep the inside of the absolute value. I'll kind of split this up so we have both. 3x plus 18 equaling now a -6x. So I have to go ahead and make sure I have the positive and negative of the given outcome in my original equation. We go ahead and solve this here by subtracting 3x on each side. That moves it to the right side from the left, cancels out on the left, and 6x minus 3x is going to be 3x. Divide each side by 3, cancels out on the right, gets x by itself, and 18 divided by 3 is 6 on that left side. Going ahead to solve the second equation, I still subtract by 3x. Still cancels out on the left, but now I have a negative 6x minus 3x, which is going to be a negative 9x on the right side. Divide each side by negative 9. Cancels out on the right side. 18 divided by negative 9 on the left side is negative 2. We go ahead and do our checks accordingly back in the original equation. So when I check plugging in a value of 6, I have 3 in my absolute value instead of x with a 6, plus 18 equaling 6 instead of x, another 6. We do the order of operations, which is going to be multiplication on the left side as well as multiplication on the right side. And then I go ahead and add 18 plus 18 to get me 36. And that matches and is a true statement. The absolute value of 36 does equal 36 there. We go ahead and check the negative 2x value possible answer here by again plugging it back into my original equation. Absolute value of 3 instead of x, I'll plug a negative 2 in, plus 18. And again, I'll have 6 times a negative 2 now instead of an x. Again, we do the multiplication on each side, so I'll have negative 6 plus 18 in my absolute value, and I'll have it equal to a negative 12, because 6 times negative 2 is negative 12. Then I simplify that absolute value. Negative 6 plus 18 is a positive 2, but I know the absolute value, like we just saw in the last equation, cannot be equal to a negative number. So this is not a possible solution. It's going to be our extraneous solution case. In example number 5, we go ahead and again have the absolute value all alone, so we're able to split it from here. I keep what's inside the absolute value, 2x minus 17, and equal it to the 4x minus 1 given. My second equation is keeping the inside of the absolute value, but now equaling it to the opposite signs on the right side, meaning that that positive 4x becomes a negative 4x, and the negative 1 becomes a positive 1. We have to make sure to do the opposite of every single term, every single sign we had on that right side. I'll kind of split it up so that way we're solving here. Okay, we solve each equation separately here. I'll solve the first one here, which is going to go ahead and have me subtract 4 on each side with x, of course. And then I want to move my numbers to the right side since I moved my letters to the left by adding 17. Cancels out my numbers on the left, letters on the right. 2x minus 4x is negative 2x, and negative 1 plus 17 is 16. Now to get x by itself, I divide each side by negative 2. Cancels out on the left, and 16 divided by a negative 2 is negative 8 on the right side. Second equation, again, I'm going to add 4x to move my letters to the left side, and add 17 to move my numbers to the right side. Cancels out the negative 17 plus 17 and the negative 4x plus 4x. Adding 2x plus 4x gets me 6x, and 1 plus 17 gets me 18. Divide each side by 6, and that comes out to be x equal to 3. Now we do our checks back in the original problem. Everywhere I have an x in the original problem, I'm now going to replace it with a negative 8. So that's 2 instead of x times negative 8 minus 17 equals a 4 instead of x, I have a negative 8 minus 1. Okay, we do the multiplication first. 2 times negative 8 is negative 16. Keep the subtraction of 17 in that absolute value. And 4 times negative 8 is negative 32. Keep that subtraction of 1. Now we go ahead and combine here. Negative 16 minus 17 is negative 33 in that absolute value. And negative 32 minus 1 is a negative 33. The absolute value of negative 33 must come out to be positive 33, which is not ever going to be equal to negative 33. So this is our extraneous solution here. Let's go ahead and check the second one. Checking my second solution here, it's going to be plugging in a positive 3 back in the original problem. Absolute value of 2 instead of x, I plug in 3. Keep the subtraction of 17, equaling 4 times 3 instead of x minus 1. Multiplication first on each side. 2 times 3 is 6. Keep that subtraction of 17. 4 times 3 is 12. Keep that subtraction of 1. 6 minus 17 gets me a negative 11 in my absolute value, and 12 minus 1 is 11. The absolute value of 11, negative 11 in that absolute value specifically, comes out to be 11, and it does indeed equal 11. So that's going to work out as a solution, and it's going to be the only non-extraneous solution for this problem, and only real solution. For number 6, I have the absolute value of 4x plus 13 equaling 11 minus x, and the absolute value is all alone already, so I can start splitting it up into my two possible solutions. First possible solution is going to be this 4x plus 13 equaling 11 minus x. And then my second possible solution is going to be 4x plus 13. Always keep what's inside the absolute value the same, but now it's going to equal to a negative 11 plus x. I do the opposite signs on every term that was not inside that absolute value on the right side. Okay, we solve both the equations down to a possible x value. First equation, I'm going to go ahead and add x on each side to move my letters to the left. That means I got to then move my numbers to the right by subtracting 13 on each side. Negative x plus x cancels out on the right, and 13 minus 13 cancels out on the left. Now I combine what's left. 4x plus 1x is going to be 5x, and 11 minus 13 is negative 2. I divide each side by 5, and that ends up getting me x equaling a negative 2 over 5. Then I go ahead and check my second possible solution. I got to move my letters to the left by subtracting x on each side, and then I got to move my numbers to the right by subtracting 13 on each side. 4x minus x is 3x, cancel out 13 minus 13. Negative 11 minus 13 is negative 24, and canceling out the x minus x on the right. Divide each side by 3 gets my x by itself, and negative 24 divided by 3 is negative 8. Now we do our checks to see if we have true solutions or if any of them are extraneous here. When I check, I plug it back into the original given problem. I have 4 instead of x, it will be a negative 2/5 plus 13 still in that absolute value, equaling 11 minus, keep that negative there, but now in parentheses I have a negative 2/5. PEMDAS tells me to do the multiplication first, so on the left side here I'm going to put 4 over 1. That way I can see if anything cancels out on the diagonal. Nothing cancels out with my 4 and 5 or my 1 and negative 2, so I'll multiply straight across the top. 4 times negative 2 is negative 8. And I'll also multiply straight across the bottom. 1 times 5 is 5. So now I have negative 8/5, but we'll work with that, don't worry. Keep the plus 13 in the absolute value next to it for now. 11, it's a negative times another negative, which makes it positive, so it's 11 plus 2/5. When I am doing this addition of fractions here, I'm going to stress how much this is now addition of fractions, not multiplication of fractions. I need a common denominator. The easiest way to do that is by putting 13 over 1 and 11 over 1. And therefore, to get at the same denominator as what's next to it, which is a 5, I have to multiply the top and bottom of those by 5. So the first fraction will stay negative 8 over 5. The second one will get multiplied by 5 to the bottom, 5 to the top here. Actually, let's do that in a different color to truly show what we're doing. 1 times 5 in the denominator is 5. To get that same denominator, same common denominator for adding fractions. And 13 times 5 is going to go ahead and be 65. Then we go ahead and do the same thing over here with 11 over 1. Multiply the bottom by 5, top by 5. That's the only way to get it is a denominator of 5, because 5 times 1 is 5, and 11 times 5 is 55. Now that we have common denominators, we can go ahead and add those fractions. When you add fractions, you're going to keep the same denominator, so negative 8 fifths plus 65 fifths is going to be a 5 in the denominator. Keep it the same. In the numerator, we actually do that operation. Negative 8 plus 65 is going to go ahead and give me a 57. So inside my absolute value, I have 57 fifths. Over here on the right side, 55 plus 2 will give me 57. Keep the denominator of the 5s the same. And again, I have 57 fifths. The absolute value of 57 over 5 is indeed equal to a positive 57 over 5. So that is a true actual solution. Let's check negative 8. I'm going to go ahead and plug it into my original given problem. Absolute value of 4 instead of x, I'm going to put in a negative 8 plus 13 in that absolute value equals 11 subtracted by a parentheses of negative 8 instead of x. Multiplication comes first. 4 times negative 8 is negative 32. Keep the plus 13. I'm going to keep the 11, but two negatives here make it a plus 8 after that 11. Negative 32 plus 13 is negative 19, and 11 plus 8 is 19. Take the absolute value of negative 19, it is going to be positive 19 since the absolute value is a distance. How far away is negative 19 from 0? Well, that is indeed a 19 distance. Positive 19 equals positive 19. This is a true actual solution.